Yeah, there's a square root. Good call. Woohoo! In fact, it's a really big square root. Right? It is. Oh, people, you're killing me. Okay, here we go. Oh, this just does not work well. It's x2 minus x1 squared plus y2 minus y1 squared. Okay. What about the midpoint formula? Find the middle of 2 points. Just find the average of the x's and average of the y's, right? Midpoint formula is easy. So this one is x1 plus x2 over 2, comma, y1 plus y2 over 2. And that's a point. Okay, remember, that's a midpoint formula. You're finding a point there, okay? So the x value is just the average of your x's. The y value of your midpoint is the average of your y's, right? Average is the middle, so that's what we're finding, okay? All right, so we want to find the distance between those 2 points and find the midpoint. Okay, so the distance is the square root of x2, which is, what's x2? -1 minus x1. x1 is -4, so if I minus a -4 plus y2, which is 2, minus a -2 minus y1. Okay? So that gives us the square root of 3 squared, which is 9, plus 4 squared, which is 16. 9 and 16 is, square root of 25 is 5. So the distance between them is 5. Okay. Now the midpoint, again, average your x's. So x1 plus x2. So -4 minus 1 is -5 over 2. And then y2 plus y1. -2 plus 2 is 0. There's your midpoint right there. Okay? Easy stuff. All right. Now for circles, okay, to come up with the equation of a circle, all right, we derive that from the same, by using the distance formula, the same formula as you do to find the distance, okay? So what is a circle? It's the set of all points that are equidistant from a given point called the center. That's all it is, okay? Now, what is that distance? What's the distance from the center of a circle to the circle? What's it called? It's called your radius, correct. So the radius is the distance from the circle, from the center to the circle and vice versa, okay? All right. So with that definition in mind, it's clear we only need two things about to know. We only need to know two things about circles. Number one, what's the length of my radius, or how big is my circle? And number two, where is it? Where's the center? Okay, that's what we're looking for. All right. So okay, so it says find the equation of a circle whose radius is r and whose center is h and k. In other words, find the distance between hk and xy. Call the distance between the 2 points r. So here's so we're going to use that distance formula again. Here's what it's going to look like. Okay, we're going to have r equals the square root of x minus h squared plus y minus k squared. All right? We don't want that big old square root there for our circles. We want to clean it up a little bit. So how do I get rid of a square root? Square it, right? We're going to square both sides. And this becomes the standard form of a circle, okay? So we get x minus h, quantity squared, plus, that should be a y minus k, quantity squared, equals r squared. And that is the standard form of a circle, where h and k are the center, and r, not r squared, r is the length of your radius. Now, the nice thing about this equation, it is extremely graph friendly, right? It tells exactly where the center is and how far out you go from the center, okay? So we really like that, okay? Like that form of the equation of a circle. Okay. Now, in its simplest form, x squared plus y squared equals r squared. That means h and k are both what? They're both 0, right? So where's the center of my circle? It's at the origin. Okay. So if I wanted to graph x squared plus y squared equals 25, looking at the equation here, where's our center? At 0 and 0, and what's the length of my radius? Yeah, it's a square root of 25 or 5, okay? So, now that's just like, duh, easy to graph. Centers of the origin. Since my radius is 5, I'll go up 5, down 5, right 5, and left 5, and make my circle. Okay. Graphing circles, piece of cake. Yes, sir?
So like for, when you label the radius, would you just say would you just say like 5 units or something like that?
It was like that, just say 5. Generally, oftentimes it'll tell you, okay, this is, it'll give you a dimension, miles, feet, inches, whatever, okay? If not, if they don't specify one, you don't put it, okay? Just make it 5. Center here is at the origin. Radius is 3. Same thing. Center right here, up 3, down 3, right 3, and left 3. And there's your circle. Okay, now we're going to move it around a little bit. So again, we want to graph them and give the center and the radius. So where's the center of this circle now? It's at positive 4, negative 2. Good. You change those signs. That's excellent, people. Positive 4, negative 2. Here's my center. So now from this point, what's the length of my radius? 3. So from this point, I go up 3, down 3, right 3, and left 3. Wow. That should be there. And there's our circle. So when you grow up, you can make good circles like me. Okay, center. Negative 5 and 1. Radius. Square root of 18, right? Now, okay, obviously, square root of 18 doesn't help us a whole lot. So let's get a guesstimate of the square root of 18, okay? So what's the lowest, so what's the biggest perfect square that's lower than 18? 16, right? So that's 4. What's one bigger? 25, so that's 5. So we know root 18 is somewhere between 4 and 5. All right, is it closer to 16 or closer to 25? 16, right? So maybe 4.2, 4.3-ish. Okay, on a graph like this, I'm not going to be able to tell the difference, okay? So we'll go roughly 4.2. Oh, gosh, 4.2. All right, so we go to negative 5 and 1. For our center, we go up 4 and some change, down 4 and some change, right 4 and some change, and left 4 and some change. And there's your circle. I am drawing some good circles today, I'm not going to lie. All right, so when you graph something like y equals x plus 3 squared, we move the graph of y equals x squared 3 units to the, which way does that one shift? Left or right? That one goes left, correct. Okay, and it's the same idea, it can be extended to the equation of a circle, right? So in other words, so when we have that equation, where does that move that center? It moves it to the right 4 and down 2. Good. Or to the point 4, negative 2. All right, now we can also go in the opposite direction here. Okay, so if we're given the equation in standard form, we can come up with the radius and the center pretty simply. Well, if we're given the center and radius, we should be able to write an equation for that as well, correct? Okay, so if the center is at the origin and the radius is 9, what is my equation? x squared plus y squared equals 81. Good. Okay, what about part B? X minus 5 quantity squared plus y plus 6 quantity squared equals, yeah, the square root of 11 squared, or 11. Okay, now, if you look at example 6 here, this is what is called general form of a circle. And general form really sucks because it doesn't do us a whole lot of good. Okay, so if you ever get a circle in general form, which you will, you need to put it in standard form. Okay? So now, with standard form, we have perfect squares. So we're going to have to do what here? Say complete the square. Yes, good job. Awesome, right on top of it. Okay, so let's review some completing the square. Okay, so in order to find the center radius here, we need to put this graph in standard form. So we're going to complete the square. So we're going to put our x's together. We're going to put our y's together. And I'm going to run that 15 to the other side. Now we're ready to complete the square. Do you remember how to do that?
Yeah.
Take that middle number, or this number right here, and do what with it?
Divided by 2.
Half it and square it. Okay? Now, when you half it, write that number down because you're going to need it. So half of 6 is 3. Write that 3 down because we're going to need that in a minute. Okay? 3 squared is 9. So I'm going to write a 9 there. Now, if I write a 9 on the left side of my equal sign, I got to put a 9 on the other side. Okay? Now, why would I do that? What is x squared plus 6x plus 9? That is a perfect square. Okay, and I can factor that into x plus 3 quantity squared. That's why we wrote that 3 down. Okay. So now I know where my x value of the center is. Okay? All right, so let's do the same thing with our y. So half of minus 4? Minus 2. 2 squared? 4. Add 4 to both sides. So again, y squared minus 4y plus 4 is simply y minus 2 squared. And then 15 plus 9 is, thank you, plus 4 is 28. Wow. All right, so where's our center? Center's at negative 3 and 2. And what's the length of our radius? Square root of 28, or roughly 5 point, yeah, 2, 5.3-ish. Okay, let's graph it. So we're at 3 and negative 2. There's our center. Up 5 and some change. Oh, we'll say right there. Down 5 and some change. About here. Right 5 and some change.
Isn't that the wrong side?
Oh, yeah, it's a negative 3, too. Good call. Yes, yes, it is. Let's go to the right, the correct center. Let's go to negative 3 and positive 2. Does that look a little better? I agree. Okay, so again, up 5 and some change. Come on. Down 5 and some change. Right 5 and some change, and left 5 and some change. Okay, I'll give you guys some good completing the square practice. Okay, so let's roll here. So x squared minus 8x plus y squared plus 10y equals 8. Okay, half of minus 8 is minus 4. Squared is 16. Half of 10 is 5. squared is 25. This is now a perfect square trinomial, and it's x minus 4 squared. This is a perfect square trinomial, and it is y plus 5 squared. Okay, 8 and 16 is 24. 24 and 25 is 49. Well, that's awfully convenient. All right, so where's the center? 4 and negative 5. Yep. Oh, come on. Okay, so now let's see if I can graph this in the right spot. 4 and negative 5. And the length of our radius is 7. Okay. All right, I'm not going to, I run out of graph here, so I'm not going to plot that one. But I'm hoping you guys can do that, right? Okay. Okay, let's do this. Let's do part C here. Okay, so again, so now I've only got an x squared here, but our y's we've got to fix. So half of minus 8 is minus 4. Bless you. Minus 4 squared is 16. So I'm going to add 16 to both sides. So now this becomes y minus 4 squared, and then that equals 16. So now where's the center? It's 0 and 4. Good. Length of my radius? 4. Okay. All right. We okay with the graph? Can handle that? Yeah, so sometimes in a case like this, where the x squared is already perfect squared, you only have to complete the square once for the y's. Like example 7. So it says, find the equation of a circle with the endpoints of a diameter at 1, 4, and negative 3, 2. Okay. So, give me some characteristics about the diameter of a circle. Okay, so twice the length of the radius, and the diameter always goes through the center. So how am I going to find the center of my circle here? There we go. Use the midpoint. Find the midpoint of the two endpoints of a diameter. You'll have your center. Okay? So again, average your x's, average your y's. So we have 1 minus 3 over 2 and 4 plus 2 over 2. Which gives us negative 2 over 2, which is negative 1, and 6 over 2, which is 3. There's the center right there. Okay? So we already know for our equation now, we've got x plus 1 squared plus y minus 3 squared equals. Now how are we going to find the length of the radius? There we go. We use a distance formula from the center to which point here on our diameter? Doesn't matter, right? We better get the same value. So we'll pick this one. Okay. So then the length of our radius. Come on. Is the square root of. And now, does it matter which point is x1, y1, and x2, y2? No. It doesn't. Just be consistent. Okay? So I'll make the 1, 4, we'll make that a 1, x1. Okay? Or x2. That doesn't matter. Freak, whatever. Okay, so we're going to go 1 minus a negative 1 squared plus 4 minus 3 squared. So that gives us, what? 2 squared, which is 4, plus 1 squared, which is 5. Sorry, 4 plus 1 is 5. So the length of our radius is the square root of 5. So what goes in our equation here? Square root of 5 squared, which is 5. And there's your equation right there. Oops, cut that off. Okay, and we will skip this bottom part because we don't use graphing calculators anymore. Some of these things, I'll tell you, we made these